And by 1993, he also gave us C45 algorithm. Same guy. So these are about decision trees. First time ever, back in the 50s, when we promised too much with AI, and after well into the 60s, nobody was listening to us anymore. Because back in the 50s, we promised we can have GPS, not navigation GPS, general problem solver. Look at the audacity. We said AI, we didn't even know what AI is, but we were promising what it can do. It was about expert systems and rules. And we were saying we can write a program with AI that can solve any problem. Today we cannot do it. And if it is my guess, in 50 years we will not be able to do it. Maybe in 100 years we will not be able to do it. We couldn't even come up with some rules. So for the first time, Quinlan, what he gave us, and this is in MATLAB and Python, and you're using it every day and you don't know. You take a bunch of numbers, you give it to this algorithm, they process it, and they construct a beautiful decision tree for you. Fantastic. The concept of entropy, information gain, which comes from communication system, has nothing to do with AI. People that come from outside of the field, they bring fresh ideas because they don't have our biases. So they bring a new perspective. So algorithms for decision tree construction, very, very important, today relevant. Today, random forest based on the same algorithm can compete with a deep network. That's amazing. Not for every application, but for some application. And they are interpretable, which means human expert can understand the results. And I can say why this decision was made. Very important. So 1995, we got SVM. We got SVM by Cortez and Vapnik. Vapnik has worked on support vector machines for almost 3 decades, almost 3 decades. He had not much possibility back in Moscow to run experiments, and then somebody asked him, come to New York, we will work together, we will figure it out. So they figured it out. They did the last adjustment and idea and development and run it, and then they showed on one of the major data sets that everybody is using today, which is MNIST, digit recognition data set, showed, oh my God, you can really do nice classification. Again, what is important for support vector machines is that it gives you the mathematical guarantee that it will find the best results. Nobody can overbeat that. With one condition, it has to be about a binary classification. Yes and no. For multi-class, we have some problems to overcome. So in 1995 and 2001, we also got random forest by multiple authors. We got by T.K. Ho and partly by Bryman, L. Bryman. So random forest, again, is important because it shows one of the major concepts of AI is either you come up with a big solution, like a deep network with 120 layers, or you come up with many, many small solutions, and then combine the forces. Ensemble learning. Weak classifier. It's very good because computationally they are super efficient. We cannot dismiss them. So people try to make them exciting and attractive by saying, okay, deep random forest. What is deep random forest? Because I have many, many layers. What? Okay. So then we came also to 1995. So many things happened in 1995. What else happened in 1995? CNN. Convolutional